Good day to everyone. We are Group 2 from 3ME-A. My name is Juan Miguel M. Bailon,
I'm John Patrick P. Benavides.
I'm Kirby Clark Sibon Caras.
I'm Lionel P. Buwan.
and we are here to present our research title, Developmental Study of Water Hyacinth as Energy Source in Binangonan, Rizal. Now let's proceed to Chapter 1, which is the background of project. The contents of Chapter 1 are as follows.
And for the background of the study, energy is essential for our daily lives, but its production and consumption have negative consequences for the environment and society. To combat these issues, there is a growing recognition of the significance of renewable energy, which is becoming more cost effective and competitive. Surprisingly, the invasive water hyacinth can be utilized as a renewable energy source through biomass conversion. In addition, efforts are focused on expanding biomass utilization, including converting water hyacinth into marketable products. With advanced technologies and increased investment, renewable energy supply is growing, providing flexible and eco-friendly options. Moving on to the objectives of the study. So for the general objective, it is to create an effective and efficient biofuel with water hyacinth as a primary material. For the specific objectives, first, to identify the required formula in creating the water hyacinth biofuel, to determine the acceptability of using water hyacinth as alternative energy source in terms of usability, reliability, and maintainability. Next, to test and evaluate the effectiveness of water hyacinth as a primary material for biofuel in terms of burning capability, ease of production, product quality, and production stability. And last, to formulate a booklet about the specific formulations in creating the biofuel. So for our theoretical framework, one of the important factors of large-scale bioenergy production is the biomass supply chain. According to Lautela et al. In 2015, such chain covers the cultivation, harvesting, treatment, transportation, and storage of biomass. After undergoing numerous processes, the produced biomass must be delivered to final consumption. Having an effective supply chain is critical in avoiding the challenges posed by the nature of biomass.
The concept of biomass supply chain is proposed to be used in the study for water hyacinth as an energy source in Binangonan, Rizal. And to summarize, the biomass supply chain will be the way to solve the area's environmental problem. According to Walker in 2013, biogas is produced during anaerobic digestion, and this process is made in an airtight container called a digester, which undergoes in the 4 different major phases. Next is the conceptual framework. The conceptual model showing the production of water hyacinth biofuel. The input shows the knowledge, which is the renewable energy source, and the water hyacinth as its main material. The process for the testing in trial and measuring, and the action or step for the production. The water hyacinth biofuel for the output itself, and last is the feedback. Next is the significance of the study. This study will undertake to propose design of a developmental study of water hyacinth as a power source in Binangonan, Rizal for the community, academic institutions, researchers, and for the future researchers. Moving on from the scope and limitations, this study focuses on incorporating renewable energy sources in terms of water hyacinth. The study will cover engineered detailed plans to come up with the digital model and the cost estimate of the process developmental study of water hyacinth as energy source.
Now let's move on to Chapter 2, which is the design methodology. The contents for Chapter 2 are as follows.
For our research technical design, the experimental and developmental research method is considered suitable for this study, as it aims to design and construct a renewable energy source using water hyacinth. For our research instrument, to gather further information on the proposed study, researchers use survey through questionnaire and testing and evaluation of product in terms of burning capability, ease of production, product quality, and production stability. Upon gathering of information through survey, results may show if it is poorly acceptable, fairly acceptable, acceptable, moderately acceptable, and highly acceptable with a scale of 1 to 5, wherein 5 is the highest and 1 is the lowest.
For the procedure and method of the study, for the first part, the conduct of the study, we have used an agile Gantt chart to document and to represent the methods of the activities of the study from the beginning up until the agreement of the final research title. So for the conduct of the design experiment, we have taken several steps. First step is the gathering of data. Second is the designing of the digester. Third is the assembly of the digester. And fourth is the evaluation of the output to ensure that it is working as intended. For the project design model, shown here is the processing model of biogas from water hyacinth through a digester. First is the water hyacinth is the main material that is fermented in a fermenter. After fermentation, it is fed through a digester where the biogas is then produced. Next is the schematic diagram of an anaerobic digester. Shown here is the schematic diagram and sample of a barreled biogas digester, which is commonly used in small-scale biogas experimentations. For the statistical treatment, the data gathered in this part were used in experimentation and development in the form of descriptive evaluation. The factors and data that are necessary to conclude this research key objectives and scopes were listed down. In addition, a questionnaire checklist was used to gather necessary data to determine the aforementioned statements above. Presentation. Thank you for listening.